Hello class, welcome to the next segment in Lab 3, and in this segment we're going to explore the idea of a Python list, which up until now we've been working with variables that only hold on to just a single value, and in this segment we're going to look at how you can store multiple different values in the same variable. So up until now we've only been working with variables that had just a single numerical entry in them, and in this segment we're going to of course put multiple numerical entries into a single variable and look at how the computer is going to interpret that. So to start things off, we have just the same variable name that we've been working with, the same variables that we know and love, just a simple variable name on the left-hand side, the equal sign. And on the right-hand side, the equal sign, you can see I have this giant character set, which begins with a set of brackets and ends with a set of brackets. And then you see I have all these numbers in here, and all these numbers are separated by commas. And the way the computer is going to interpret this is when it sees the brackets here, it knows that this is going to be a list of entries or multiple different entries. And this also, sort of a side note, list is just one topic that we'll look at. We'll also look at another way of doing this, which is referred to as an array, but that'll be a topic for a later segment. But for now, we'll just get sort of an initial bearing on how exactly this works by taking a look at just a simple list. So again, we have the set of brackets here, we have the numbers, and then the individual entries in the list are separated by commas. So this is the very first entry in the list, this is the second entry in the list, the third entry, then the 1, the 5, the 9, the 2, the 6, the 5. Each one of those entries is separated by commas, and that's how the computer knows that those are in fact individual entries and they appear in that order. So now we have this wonderful list that has all these wonderful numbers in there. Now comes the question, how do we actually access information within the list? So there's a couple ways that we can do that. First, I'm going to go ahead and demonstrate what happens if you just type the name of the variable. So if you just type the name of the variable with nothing else, then you just get the entire list. The entire list is given back as the result. But if you want to pick out an individual entry within the list, that's where these other brackets come into play. So here I can access an individual entry out of a list by typing the name of my list, or the name of the list in question, which is called my list. So notice that these two variable names do in fact match. And this is important to keep in mind if you've got multiple lists in the same program. You want to make sure that you put the list here that you actually want to pull the information from. So just make sure that if you're pulling information out of a list, make sure that list appears exactly the way it was defined. Otherwise, it's not going to work for you. You either get the information that you don't want, or you might just get an error message if that list doesn't exist at all. So you type the name of the variable that's holding on to your list of entries, which again is my list, again followed by a set of brackets, and then this number you put inside the brackets is referred to as an index, and that just basically tells the computer which entry out of that list you actually want. And here's where things get kind of funny. The computer, we humans like to start counting at 1. But the computer likes to start counting at 0. That's just how the computers have worked. That's how they've worked for the past several decades. They started counting at 0. So what we would call the first entry in a list, which would be this 3, the computer is going to call the 0th entry in the list, if you will. So what we would call item number 1, the computer would call item number 0. So my list with the 0 in the brackets will in fact tell the computer that we want this 3 at the very beginning of the list here, the very first entry in the list. You can see we do in fact get that result back. We tell the computer to access whatever that entry is and then print out what that entry is, which is just the 3 here. And if we want, say, a different entry in the list, then we can just put a different number in the brackets here. So again, the computer starts counting at 0. So this is what it would consider to be entry number 0. What's this highlighted 3 here? It would call this entry number 1, entry number 2, entry number 3, entry number 4. So by putting the 4 in the brackets this time, exact same thing as what we had up here with the exception of what's in the brackets, this will tell the computer it wants entry number 4, which is just the 5 that's highlighted here, and running the program does in fact confirm that. Now here's something that's kind of unique to Python. You can actually put negative numbers in the brackets. With other programming languages, this doesn't work. But with Python, you can put negative numbers inside of the brackets here. And again, that's just telling the computer when a specific entry out of my list, or out of the list in question. Putting negative numbers in here means I want this to the last entry in the list. So putting in -1 means I want the very last entry in whatever the list is. Putting in -2, which will be the next example we look at, means I want the second to last entry in my list. -3, the third to last entry. -4, the fourth to last entry, and then so on and so forth. So just having my list with the -1 in the brackets here means the computer is going to look for the very last entry in the list, which is just going to be the 5 at the very end here. And just giving that a trial run, we do in fact confirm that result. And if this pattern actually holds, then we should get something that's a little less ambiguous. So if this is in fact the way it works, then this -2 should access the second to last item in my list, which is this 6. And running this program does in fact confirm that. We did in fact get the second to last entry in our list up here. Now we're going to demonstrate what happens when you do something like this on line 8. So again, if you look at how the computer is going to sort through this information or access this information, again, this is entry number 0, entry number 1, entry number 2, number 3, number 4, number 5, number 6, number 7, number 8. What happens if you put a 10 in here? If you put a 10 in here, you want entry number 10 out of the list. Since the list does not have an entry number 10, you would get this error message. List index out of range. This is something that you might see fairly often. In fact, it's something that I see fairly often, even though I have a lot of programming experience. I see this quite a bit. I just get this error all the time, either because I made a silly mistake or whatever the cause might be. But you tend to run into this error a lot, especially when you're trying to analyze any sort of complicated data set, which is what lists are designed to handle. It allows you to much more compactly and efficiently handle really large sets of data, which you'll get sort of a first-hand experience for that in the programming project. But this lists are really nice to have, but sometimes you get these annoying little error messages that basically if you see this error message, you put a number in here that's either too large, or you can put a number in here that's also too negative. So again, the 10th to last entry in the list does not exist because this goes -1, -2, -3, -4, -5, -6, -7, -8, -9. There is no -10 entry, so again, you get this error message, list index out of range. So that's going to do it for a first look at lists, or for this part of it. There's another thing that I want to introduce, and this is a function that you will also get a lot of use out of, especially if you do any sort of intensive data analysis in Python. And this is something called the Len function. Simply put, the Len function, you give it the name of a list or a variable that's a list. So my list is the same my list that shows up here. So again, the name of my list, the name of the list in question is my list, MY_LIST. By putting this variable name in the Len function, the computer is going to count how many entries are inside of that list, and then that number you get back is going to be the result here. So here I have capital N on the left hand side. The equal sign is equal to Len my list. So this right hand side, the equal sign, is going to count how many items are in my list, get that number, and then store that number in the left hand side, which is this variable in here. That is all the Len function does. All it does is count how many entries are in a list. That's it. I see a lot of confusion about this Len function, especially when things get a little bit more complicated, but that's all the Len function does. Only that, nothing else. All it does is count how many items in our list. It does not do anything else at all. So hopefully that will clear up all the confusion that might surround the Len function, but that's all it does. All it does is count how many entries are in a list. And if we run this, so earlier we counted that there are in fact 9 entries in the list. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we would expect this variable n to hold on to a value of 9. You can see we do in fact get that result when we run this program. We get a value of 9, which is what's being stored in this variable called capital N. So again, just to reiterate one last time to hopefully avert the confusion once and for all, the Len function, all it does is count how many items are in a specified list, and that specified list is what's inside the parentheses here.